हेलो एवरीवन। आज हम पढ़ेंगे गैस क्रोमेटोग्राफी के बारे में। तो इंट्रोडक्शन ऑफ गैस क्रोमेटोग्राफी। द टर्म क्रोमेटोग्राफी कवर those separation technique in which the separation of compound is based upon the partition or distribution of analytes between two phases in a dynamic system. In gas chromatography, we have gaseous mobile phase and a liquid or the solid stationary phase. Gas and liquid chromatography are the both carried out in a column, where the planar chromatography or the thin layer chromatography is carried out on the plastic metal or the glass sheet coated with the silica. In gas chromatography, the system in which the analyte are partitioned between a stationary phase and a gaseous mobile phase by definition. Therefore, the compounds to be analyzed must be volatile from the present in the gas in the experimental condition. In order that they have been transported through the column, gas chromatography basically arranged as gas carrier, then column, then detector, then analyzer. Gas chromatography consists of gas solid chromatography and gas liquid chromatography. In both types, the gas is used as a mobile phase and either solid or the liquid is used as a stationary phase. Gas solid chromatography is not widely used because of its limited number of stationary phases available. In gas solid chromatography, the principle of separation is absorption, and gas solid chromatography is used only in case where there is a less solubility of solutes in a stationary phase, which is rare. Principle of gas chromatography. The principle of separation in gas liquid chromatography is partition, and gas is used as a mobile phase. Liquid, which is coated on to the solid support, is used as stationary phase. The mixture of components to be separated is converted into vapor and mixed with the gaseous mobile phase. The component which is more soluble in stationary phase travels slow and elute later, and the component which is less soluble to the stationary phase, they will travel faster and elute faster. The component which is less soluble in stationary phase travel faster and elute first. No two components have same partition coefficient for the fixed combinations of a stationary phase, mobile phase and other condition. Hence the components are separated according to their partition coefficient. Partition coefficient is a ratio of solubility of substance distributed between the two immiscible liquid at a constant temperature. Gas solid chromatography compares the technique which with an active solid as a stationary phase. Separation depends on the difference in adsorption of the sample component in inorganic absorbent, silica gel, aluminum, carbon black, or on organic or absorbents such as. Separation can also occur by a size illusion mechanism, such as the separation of gas on synthetic molecular sievings. Solid chromatography is performed on the packed column or open tubular column on the wall of which the thin layer of the porous material is deposited. The gas solid chromatography nowadays it is used only for the special separation problem. The gas solid chromatography are therefore referred to the tailor-made columns. Instrumentations of gas chromatography. First, the modern gas chromatography consists of following basic components as represented in the figure: gas carrier, pressure regulator, then flow meter, then sample injector, and then column chromatography. This is column oven, detector, amplifier, and readout. The gas supply system, the main purpose of carrier gas is to transport a sample component through a column. For selection of carrier gas, following factor must be considered. It should be chemically inert. It should be suitable for detector to be utilized the type of sample analyzed. It should give a best column performance. It should be readily available, cheap, high purity. It should not cause the risk of fire or any hazard. In gas carrier, the commonly used gas are hydrogen, helium, argon, and nitrogen. The most application with the thermal conductivity detector, either hydrogen is used or the helium is used. The column oven. This is a normally accurate temperature control fan blow oven with adequate space accommodated column and with an even temperature distribution throughout the oven. Ovens can normally be temperature programmed at a variety of rates with isothermal period set as desired. Flow meter and flow regulator. A high pressure gas cylinder in which the gas carrier is filled in a compressed form in which used as a carrier reservoir. The cylinder is also attached with the pressure regulator to reduce the control of gas flow through the separation column. The flow meter is used to measure the flow rate of the gas carrier. They are rotometer or the soap bubble flow meter. Sample injector system. Sample injector is very important and critical because the gas column chromatography make the use a very small amount of the sample. A good and ideal sample injector must should be one of where the sample is not be decomposed at the point of injection, create a pressure, undergoes a friction adsorption component during the course of the transfer of the column. The gas carrier is conducted from the gas reservoir to the sample port injector. Since the solutes to be chromatographed must be in the vapor state, the injector port is heated to a temperature which will ensure the rapid vaporization but not the thermal degradation of the solute. The injection port is placed so that the sample is injected directly into the gas carrier. Column. The column is the heart of the gas chromatography. Column is in which the separation of component take place. This must be added the source and control of the gas flow through the column. A mean of the sample introduction and the mean of detection of the components as elude the end of the column. Since the temperature will influence the volatility of the analytes, the column is rapid thermostatically controlled oven. Column is made of glass or the stainless steel. There are several types of column. Detector. The earliest date the gas chromatography there has been much interested in both the quantitative and qualitative aspect of the technique. It is a natural that having been able to separate the mixture of the component, detector were very primitive and many cases of machines of the detection are unclear. Sometimes the detector had their origins as gas analysis. The internal geometry was far and from ideal for their application in the dynamic and small volume gas chromatographic environment, where the concentration of analyte in the gaseous medium were low, where the fast response were initially if the eluting peak were to be faithfully monitored. All the detector monitors resolved solute, measuring the changes in the composition, rising the variation in the elute components. General requirement for detector highly sensitive to the small concentration, physically suitable, capable for operate a maximum column temperature, wide range sample, easy to operate, rapid response. Types of detector: thermal conductivity detector, ये इसके बारे में आप खुद से पढ़ लेना। इलेक्ट्रॉन कैप्चर डिटेक्टर, डायग्राम ऑफ इलेक्ट्रॉन कैप्चर डिटेक्टर, photo ionized detector, then nitrogen phosphorus detector, flame photometric detector. Third detector is flame photometric detector. Applications of gas chromatography. These are the applications of gas chromatography. You can read from this video.